just to give a little level setting, I'm going to run through my slides and run through my talk. And then afterwards, I'll check the chat and answer any questions that you all have, because I got my full screen up, so I can't see the chat right now. But first off, thank you so much for having me on here. I'm really excited to chat a little bit about how Core Web Vitals will affect Google rankings in 2021. So my name is Lee Robinson. I'm a solutions architect and handle DevRel at Vercel. And if you haven't heard of Vercel, it's totally okay. Vercel is the fastest way to deploy your front-end applications. And we really enable collaboration by giving front-end developers the tools to create not only high-quality applications, but performant applications as well. So if you haven't tried Vercel, check it out. Go to vercel.com/new and deploy a project in a few minutes and see what it's like. So today, I'm going to be talking about Core Web Vitals. And we're going to start off with some background and introduction. Why should you care about performance? Why should you care about SEO? And how will that affect the business overall? Secondly, I'll dive into what these Core Web Vitals are and how they affect SEO. We'll talk about how to improve that performance. And then finally, how can we measure that over time and understand if the changes that we've made actually are beneficial and they have the effect that we want, which is critical, right? So first, let's talk about some background introduction. Why should we care about web performance? And what does this mean for your company or your business as a whole? In 2009, so if we go way back, right? 2009, Amazon found that for every 100 milliseconds of latency, it led to 1% fewer sales. And that's pretty drastic when you think about things on the scale of an Amazon. And interestingly enough, we fast forward a little bit, we see that Walmart in 2012, 100 milliseconds less latency, so the inverse kind of, led to 1% more revenue. So similar findings, essentially saying that when we improve performance, we see more sales. And it seems obvious, right? But when you're at the scale of a Walmart or an Amazon, these little improvements to the performance of your page can lead to multi-million-dollar benefits for the business. And not only that, better performance is going to lead to better SEO. I really like this example of the founder of remoteok.io and Nomad List, who tweeted out, "Did Google search do an algorithm update? Because for some reason, I'm getting so much better SEO." And it turns out they did, and they're influencing how your site performs more heavily. And you can see in that graph in the Google Search Console, it had quite the drastic impact, actually. So what are these things? What are these Core Web Vitals that I keep mentioning? And how do we actually measure the real user experience of people using our site? So Google as a whole has been advocating for web performance for a long time, especially the Chrome team. You know, they've been tracking ways to understand the performance of your site, and they've done a lot of research into this. But in the past, I would say there was almost so much, it was intimidating or confusing as a product engineer or a developer trying to implement these changes to know what are the most important ones? What are the ones that I should focus on? And really a breakthrough was made when the web performance group and Google came together and said, all right, we're going to introduce these vitals, meaning these are the ones that we think are the most important. We're going to give a more focused, opinionated set of guidance to developers. And we're going to call these Core Web Vitals. And we're going to include 3 Core Web Vitals. So these are going to help you understand how real users are using your site. And we're going to use these to influence search ranking. So starting in May of 2021, these vitals I'm going to talk about today can help you get better SEO. The first one is LCP, or largest contentful paint. And this is going to help the perceived loading speed of your page. So basically the timeline from when your page's main content has fully loaded. And most of the time, these are large things like images or videos. So having that fast LCP helps Google and other trackers understand whether your page is useful. You want that content to load very, very quickly. And alongside of providing these vitals, they also provide guidance on what's good, what's and what's pretty bad. So you want to aim to have an LCP of less than 2.5 seconds. That's the first core web vital. The second is first input delay, or measuring interactivity. So the time from when a user first interacts with a page, whether they're clicking a link or tapping on a button or using some kind of custom JavaScript powered control, the first input delay is the time between that and when the browser is actually able to begin processing the event handlers for your responding to that interaction, essentially. So if I click on a button, I want it to execute. I don't want it to be frozen and act like the page is, non-interactive. I think we've all seen this before, and we know how frustrating of a user experience it is. So because of that, really the gold standard for first input delay is less than 100 milliseconds. If you can do that, then your site is going to be very performant. The third core web vital that we're going to talk about today is cumulative layout shift, or CLS, which is measuring visual stability. So I'm sure we've all been on articles online where suddenly something jumps and interrupts you in the page. Some text moves, you lose your place, a banner pops up. It's a really frustrating experience. And I think that we can all relate to something like this. You're trying to place an order. I clicked the wrong thing because a subscribe modal popped up in front of my face. And we want to prevent doing things like this. Now, an example of a good way to do this is to use things like loading skeletons. And as you notice, when this page loads in, you're not seeing the layout shift at all, which is a better experience for the user. The things don't move out from underneath them when they're trying to click on things. So these are called loading skeletons. So the three core web vitals are LCP, FID, and CLS. Now, these are the three most important. There's all sorts of different ways that we can measure performance. And there's also the first contentful paint too, which is another important metric to look at. But overall, Google's recommendation is, hey, if you nail these three, then you're going to be doing good. So it's important to understand that. So we know what they are. We've talked about these web vitals. You have a bit of an understanding of what they are, how they're going to impact search. But now, how do we actually improve the performance of things? And what are these practical strategies that we can apply to any sort of application that you have? Now, today I'm going to talk a little bit about Next.js, but a lot of the things that I present on here can be applied to really any solution that you want, because it's just improving the fundamental performance of your website, whether you're using Next.js or you're using Svelte or whatever you want to use. You can take these same principles and these same ideas and apply them anywhere. The reason I want to talk about Next.js is because obviously I work with Next.js and I really enjoy using it, but also some of the biggest companies in the world use Next.js to use React in production. So you might be familiar with some of the companies on here, and lots of people are choosing Next.js to get these performance standards included by default out of the box in the framework that they choose. Okay, so that's a lot of talk. Let's get into some actual things that we can do. The first strategy for improving your performance and improving your SEO is pre-rendering content. What this means is you're going to be generating HTML in advance for each page on the server. Now, people who have been around for a while are thinking, okay, that's how the web has worked forever, right? And you are correct. But as we transition to more client-side applications, more single-page apps, the pendulum kind of swung back to the SPA world. Now, what we're realizing is generating that HTML on the server, doing server-side rendering or static generation allows Google or other crawlers to index your content immediately. So not only is it better for performance, but it also allows you to get that content indexed immediately. Now, there's a common misconception, I think, that if you're doing an SPA, that Google's not going to index your content or something to that effect. And that's not true. That's not what I'm saying. It will index your content. It's just not immediate. So when you want your content to be indexed immediately for the best SEO, you want pre-rendering. And one really cool thing about Next.js is automatic static optimization. And basically what the framework does is it understands if your React component is blocking data requirements, if it's fetching some data and displaying it on the screen. If it isn't, then it knows that that page can be automatically statically optimized to just some HTML. And you can just serve up that HTML and you don't have to worry about anything. So it's great that frameworks like Next.js can take advantage of this and provide these good defaults for you. But, frameworks like Nuxt do this as well, and other meta frameworks that are on the hybrid scale of allowing people to do multiple types of rendering strategies. That's number one. Number two is optimizing images. Images are huge. They make up so much of the web that we use and love today, and ensuring that we have properly sized and properly served images is crucial. So a couple quick things to hit on here, and then I'll show some examples. We want to use width and height properties to prevent layout shift, CLS, as we touched on, that core web vital. So using these tells the browser how much space to allocate for the image that you're trying to render. Secondly, we want to lazy load images when they come into the viewport. So if I'm looking at the top of a blog article, I don't want to load an image that's all the way down in the footer. We can use modern image formats like WebP and AVIF if the browser supports them. We can serve the correct size images based on your viewport. And finally, you can provide blur up placeholders for a little bit better experience when loading. So to give a little demonstration of what lazy loading looks like, let's say we're on this blog post, and as we scroll down, you see the network tab, we start to load all of the different images as they come into viewport. And you'll also notice that they're using WebP because Chrome supports using WebP. And the great thing about this is these best practices are just included in Next.js by default. What does this look like in code? I'm glad you asked. We have Next image, which is this image component that isn't necessarily a drop-in replacement for an image tag, but it functions very similar. So provide a source to some image, whether that's a local image or a remote image, give it an alt tag, define how much space you want to allocate for the image. And then there's also more advanced things you can do here with different layout types, but we won't get into that today. I want to show what the underlying HTML looks like for potentially a page that you're on, and focus in specifically on that image component. There's a few things I want to highlight. One, it's just HTML. This component isn't doing any wizardry where it's not just making something up. We're building this on the foundation that HTML provides us, things like source set and using the properties that are directly on the native image tag. But if you look at number one here on the screen, we provide this wrapper around the image component so that we automatically handle responsiveness and maintaining an aspect ratio. So you don't have to worry about that, which is great. Number two, if you look at the source of the image, we have _next/image, which is this proxy URL that the framework uses to do the image optimization. Now, this will work out of the box with Vercel, but you can provide any loader that you want to use any source. And I'll show that here in a second. And the third one is source set. So source set will allow you to serve the properly sized image depending on the viewport and the device that the browser is using. So it's great that we can take these HTML standards, these web performance standards, and include them by default in a framework like Next.js. So I was talking about those loaders. Let's say I'm using Next image and my images are in AWS S3 or they're in Contentful, right? I want to load those images so I can provide this custom loader that gives me access to the source, the width, and the quality. And then I can allow Next.js to do that automatic image optimization for me and get back an optimized version of my image. So this is really great. We've seen amazing returns on improving core web vitals for people who optimize their images and they use the automatic image optimization and image component in Next.js. The next one I want to talk about is optimizing fonts. This is the number two big thing on the web for improving your performance. Actually, 82% of web pages use custom web fonts on desktop. So you're probably having to load in some kind of font, most likely from something like a Google Fonts. And the recommendations for how we load performant, high quality web fonts have changed recently, just as of last year. So it's a good time to brush up on the best way to do these things. A couple things I want to highlight: using a variable font, which I'll talk about a little more, preloading your font, self-hosting it instead of Google Fonts, and using font display optional to prevent layout shift or CLS. Self-hosting instead of Google Fonts is an interesting one because it was kind of common practice, or maybe it just seemed like that's what everybody did in the past, because Chrome specifically would allow you to share a cache across sites. So if I went to the Material UI docs and it loaded Roboto, the web font, and then I went to my site and it was also using Roboto, you got to share that cache. And that was a perceived performance benefit for people on the web. That's great, right? Well, as of 2020, Chrome no longer allows cross-site cache sharing for security. And Safari also doesn't do this as well, and hasn't for a while. So that argument is kind of null and void now. It's better to self-host your fonts so that you can, have a more quickly resolving network request to fetch something on your own domain, and also preload that file, which we can show right here. So if you want to improve how fast your font loads, we can tell the browser, hey, the font is critical to the rendering path of getting some text on the screen. We want to prevent that layout shift, that flash of unstyled text or invisible text when your web font loads in over your fallback font. So let's preload this font file. And then let's use some of the other tricks that we talked about, most notably using a variable font and either using a Unicode range to subset it, using a Unicode range to subset it, which is essentially getting rid of all of the things that you're not using in the font file. There'll be all kinds of glyphs and characters that you don't need, especially other languages if you're not doing multilingual site. And then you can also actually subset the original font file too. And then font display optional. What this is going to do is the browser is going to try to resolve that network request to fetch the font. And if it can't fetch it in time, let's say I'm on a really slow connection, then it will serve up the fallback font. And the difference between this and what the default browser behavior is like is there isn't going to be that swap where you see the flash of the fallback font come in. It will determine that very, very quickly, such that if you have good enough internet, you'll get the good font. If you don't have good enough internet, you get your recommended fallback font. So it's really the best choice for performance and loading web fonts. I wish web fonts weren't this difficult, but they seem to be difficult for some reason. So we want to include things like this in frameworks like Next.js and make it easier for people to do these right things. Okay. Now, how do we know that if we actually did all these things I talked about, it would improve the performance for real users? You might think, okay, I've ran Lighthouse before, I've ran PageSpeed Insights, which is what we're looking at here, and it's told me a little bit more about how my site's performing. It's told me a little bit more about these core web vitals. And the distinction to make here is this is a great resource, but you have to remember that it is lab data. This is simulated in the lab. It is not how a real user is perceiving or interacting with your site. These tools help you identify issues that you might be able to resolve. But what we really want is to take this to the next level and understand how real users are using our site. And we have been using this through a product called Vercel Analytics, which supports not only Next.js, but Gatsby and soon Next.js as well. And really the difference here is if you look at the 96 of the real experience score, this is like your overall health of your site. And you can think about this. This is how Google sees your site too. You want to have this in the green so that your site is fast, performant, and ranking highly on search engines. And the critical distinction here is see 18,000 data points. So in the last day, this is how 18,000 real users have actually interacted and viewed this site and how the performance was for them in the wild. If you look down at the bottom, you see that we have the 3 core web vitals. as well as first contentful paint, allowing you to understand, what do I need to do to optimize these levers? And more importantly, visualize it over time. Those dotted lines, those dash lines, are actually deployments of your application that you can see juxtaposed over time against your score. So if you introduce a really bad performance regression, hopefully not, but it happens, you'll be able to see that line drop. You can go in and say, oh, that's not what I wanted. Let me just revert that PR or re-promote that old deployment to production and fix the issue that you saw. So this is really critical, especially breaking it down even further to kind of a per page or per URL level to get just really good insights into where can I optimize, what's working well, what's not working well, and how can I ensure that real users are having a good experience on my site. Now, this is something that we've been really thrilled to see customers of Vercel like HashiCorp use and love, so they can understand how this matches their performance goals. Companies like HashiCorp really care about performance, and they want to ensure that all of their sites across the board are performant from day 1 to day 1000. And tracking this over time is a really critical piece of that. So that is how you can measure your performance over time and understand how it changes. That was a really quick intro into Core Web Vitals, what you can do to improve and measure performance. And hopefully you have a better understanding of how to prepare for the Google algorithm changes to ensure that your page is ranking highly. I'll be in the chat answering any questions that anyone has. But thank you so much. I really appreciate it.